actually talked about a plotting program, basically in here. And I showed you something like magic, which not only allows you to pass values, data values into a function. I taught you actually how to pass a function into a function. So how does that work? And I want to repeat this topic today using another example. And the key idea is the concept of object, class, and class hierarchy in Java. Java and several other languages are popular languages called object-oriented language. And this, I hope that in this lecture you'll learn a little bit about the object, the class. A class is a kind of object. Class, the word class here is synonymous with the word kind. So one class is a one kind of object. So this you can review later. Let's start with another program. So here I wrote a small program here. It's called Drawer program. It's again a graphic program. And as you can see that this is as a package. Object example. What does package do? Package basically groups several of these things you want to group together, just like a directory.
So it's just to organize.
Yes, you can think of it that way, at least for now, just as a way of the organization. I don't want to put the thing actually in the default package anymore. I just create a directory and then put them here. So the way you can do this is, well, you can right click, new, class, and then instead of using default, you put a name here. And then they will create a structure for you. So it's trivial. And now I create a draw program. This part, hopefully you are already familiar with. It's a graphic program. And it has a public void run, which you fill in your code to draw something, and it will draw for you. And then here I defined another class called dot. So what is dot? Dot basically is another class. And you can see that a class can have some data. So basically here, it just have some data you define. You can group certain data into a class, and when you instantiate it, it gives you an object contains the data information you want. So dot here is basically just two integers. And that's very simple. And you have two private fields. Private field means what? Private fields. Have you seen the videos, the lecture video?
The one which is like it only applies to this class.
Private field means that only this class itself can modify this, can read and write this thing. Other class cannot read or write this thing. So let's say actually I decided otherwise. So basically I'll just say it's a public. It's a public thing. And then I don't need this anymore. So this is the simplest class. It's dot. And this dot has two fields. One is x, one is y. And how do I use it? Well, I can create a new dot. by just calling new. And this will call the constructor of that class. Call the constructor of that class, and which will create an object of this kind and then return it to you. So I assume that you already watched the video, so if you are confused of any of these concepts I'm mentioning here, go back to the lecture video where they talk about class, objects, constructors, and things like that. So here I have a class dot which has two fields, and at the outside of this class in this program I create an object of that class, which means that that object dot has two fields. So dot x is an integer, which I can give it a value 100, and dot y is another field which I can give it another value. I don't care. So this is like a single object has two fields, and these things I can manipulate it. I can give it a new value and I can read it out. So I can have another function called draw dot, which takes, guess what? A dot as a variable, as a parameter. As you can see that this parameter is an object. This object has nothing but two data. So this part of the thing, this part of our meet, we talk about how we can encapsulate that thing, data inside a class. So you can see that, well, I have a dot, and then I can use that data inside the dot. So I can create a geoval out of geoval, and then the position of that oval is decided by the dot. And then the diameter of that geoval is always 1. Now I can just add it. Here, I can call draw dot. So this is a very simple demonstration of how do you use a class. A class contains a variable, contains two fields. Very simple, x and y. And we create a dot here, and then we initialize this value with these constants, and then pass it along. When we pass this along, we essentially pass these two information along, so that the other function here can use this information. This information we defined here is passed along from here. So we're just passing information here. Nothing fancy. You can actually just replace this with two integers. It will be essentially the same. But giving a dot meaning that I gave it a semantic meaning, and it tells you that the x and y are related. They are the position of a dot. So that's just a semantic meaning. And this is simple. Any questions? Okay. Now what if I, well, let's see whether I can run it. So if I run it, what do you think will happen?
There will be a dot at 100, 200.
Okay, let's see. It's here. Pretty hard to see, but you can see the dot here.
Is that 100, 200? No.
It's about 100, 200.
Yeah, that's right.
So that's about it. And now we can actually try several things to get familiar with several of the concepts here. This is public. What if I change it into private? What will happen?
You can't edit it from the other class.
Yes. So private means that only this class itself can modify it, and you cannot modify it here. It says that the field.x is not visible. Private means that it hides this information from the outside class. Information hiding, and it's a very important concept. And I encourage you to go back and review the lecture video, Stanford lecture video about information hiding. Now you hide the X and Y from the outside world. Nobody can see this anymore, so this doesn't compile. But what if I still want to be able to assign these values? Well, we already see that the class can contain data. So the class can contain data. This is the data it contains. Not only it can contain data, it can contain code. Code as in function, method, whatever you want to call it. So the first one we want to say is that we define a constructor. So a constructor is a special method which has the same name as the class, but with no return value. And it can have parameters. So now I can set the axis as follows. Now I can set it value. How do I use this constructor? This is basically here. So when you say new dot, you are calling the constructor. And the constructor needs two parameters, x and y. So since I want x to be 100 and y to be 200, I give it the value here. Now looks good? No, there is a problem. This thing, I cannot read it either. I cannot change it, I cannot read it. And what if I do want to read it? Well, you have to delegate to the class itself. This class, inside here, you can read it, but not outside of it. So I can give another method, public int get x, which does nothing, just return x. And then I can have a public int get y, and which just return y. Okay, so now I can get the value of x and y. So instead of accessing them directly, I use that method. Okay, if I run it, what will happen?
The same thing as before.
Exactly the same thing as before, because although we changed the way we write it, we didn't change the logic. Here we initialize. Here we still initialize x to be 100 and y to be 200. And here we still use the same value carried along by the object dot. So although the way we write it changed, but the semantic didn't change a bit. So you can still see the one lonely, small, barely visible dot. Okay? And so now you see that the class, I said that class can contain data, which is here. And then it can contain code. These other code which knows how to manipulate this thing, and you trust your code to manipulate the private field, and you don't trust other people to do it, to change it, or even to read it sometimes. In this case, you do trust others to read it, you do this, you give it together. And if you don't want others to read it, you don't need to. So, for instance, I don't want others to read it. And what's the dot's meaning if I don't want others to read it? Which means that others cannot use this to carry the information anymore. So once you said it, you cannot read it. And what's the use of that? That sounds useless. Well, I can do something. So basically, I can draw it. So here, it draw a dot. And I can teach dot to draw by draw itself. So I can have another one, public void draw. And I can create a GOO. I can create a GOO, and then I can just give it my own field, which I know, and I can manipulate. And then I want to add it. Well, there is a problem, and this object doesn't know about add. I need something else to add it to. I need a canvas to add it to. So who knows how to add it to? Well, this graphic program knows how to add it to. So for the dot to be able to draw itself, I need a canvas.
So you need a graphics.
Yes, so I need another field. Oh, I spelled it wrong. I call it canvas, and then I initialize it here. So I need another parameter, which is graphics program. And now I call it canvas. Now I can use that. So instead of let this program take care of the drawing, I let the class itself take care of the drawing. Now the others, I don't want them to see my position. I draw it myself. I don't want to show you my position. Just take care of it for you. So in this program itself, I probably don't need that anymore. So I don't need this anymore, and I do need to give another parameter to this, and then I can call dot draw. And if I actually do this, what do you think will happen? If I run it, what?
The same dot.
Yes, the same dot.
So just different ways to write it.
The different ways to write it, and then it seems that you begin to get bored of this. What's the meaning of this? Bear with me. So have you learned the concept of an array? Okay. So here I created one dot. I can actually call this many times and create 3 dots, call them dot 1, dot 2, and dot 3. What if I actually want to create 10 of them or 100 of them? And then I don't want to write 100 different variable names. So what do I do?
You can make a for loop.
So I create a dot array. So array to call dots. Because it's an array, it contains many dots. And then I create a array. I need to initialize it with how many values you want to write. Let's say 100. So this basically creates an array of 100 dots. Position an array.
But why do you use brackets? Like,
That's just a syntax. This bracket means that this means a dot array. And this just create a thing which contains all those, a container. You can think of a container of a drawer of 100 slots.
So it's kind of like a for loop.
No, not yet. This is not a loop. This is an object. That object is, you can think of as a drawer. That drawer has 100 slots, and each slot must be a dot. Okay? And then we have the drawer, and the drawer is empty. I will want to fill those drawer with dots. So we how do we fill those drawer with dots? We can say actually dots 0. This means that the first slot equals new dot 100, 200, this. And then dots 1 equals new dot 101, 201, this. And then so on and so forth. Apparently you don't want to write 100 of those. And so
No, you can't.
yeah, that's silly. That's just silly. So I write a for loop which I equals 0 smaller than what?
100.
100. And then I plus plus. Again, I introduce the concept of array here, and which is also covered by the Stanford lecture. So, and then we say dot I equals new dot I 200 plus I and this. So we want to draw this all on this program.
Draw a line. Yes.
And then we draw them. We cannot say this. We cannot say that.
Dots.
This does not work. Why?
Because it's an array now.
Yeah, because dots is a drawer of array. It's the container itself is dot. The container doesn't know draw. Only dots know how to draw itself. So I still need another thing.
How far?
Oh. Hello. you missed a part, but don't worry, we recorded it, so you will be able to see the video later. And okay, so to recap a little, we talked about a class. A class can contain data, and here's this data. And a class can contain code. The code should know how to manipulate this data. And then the outsider can use this code to do things that are allowed defined by this class. So here, dot have the data x and y. You can think of them representing their a single dot position on the canvas, and then it has a canvas itself. And when you construct this dot, you initialize these three. You say its position and which canvas it belongs to, and then it knows how to draw itself on that canvas. And now here I create an array of dots. So array of dots is like a drawer of 100 slots, and each slot should be a dot. And here I initialize and fill those drawer, each one of those slots with a different dot. And then I draw them. And if I run this, what will happen?
There will be a line.
There will be a line. Yes, there will be a line. This is a 100 dots creating a line. So that's a class which has a method and code. There is another very interesting aspect I haven't touched yet, which is class hierarchy. What is a class hierarchy? Well, a dot is something can be drawn on a canvas. And there is a similar kind of thing which can also be drawn on a canvas, which is a line segment. A line segment can be described as 2 points and all the points in between. So if I want to describe a line segment, I can create another class called line segment. And then this time it has 4 fields. Private, so int star x, private int, I should just use a smaller x1, y1, int x2, y2. So you can think of them as actually 2 positions, 2 dots on a canvas, and then you draw a line segment between them. And so, of course, to be able to draw them, I still need a canvas. And similarly, I will need a constructor. A constructor which has these two, so left x, left y, right x, right y. this yet. Oh, that's why. And so I need to initialize them. X, X, Y, Y equals Y, X2 equals X, Y2 equals Y, and then equals C. Now I can actually have a similar draw. Here I can create a G line with x1, y1, x2, y2. Oh, there's no G line. Let's see. Let's go to our. This is the Stanford. This is the graphic program belongs to Stanford Library, and this is the API packet. Document of the library. And let's see whether we can actually. Wait, we do have a G line.
You didn't capitalize the L.
Yes. So we do have a G line, and that G line has a constructor which has 4 values. So and then we add it. Now you can see that this one is actually very similar to that one. Dots and line segments are very similar. I can actually basically just do pretty much the same thing here. So I can do a line segment and what's wrong with this one? I can create a line segment and then I can draw it. And if I run it, you can see that this is a line segment created by a whole bunch of dots. And this is a line segment just created by a line.
You can create.
So currently still there is not much of a very interesting part. I haven't reached that very interesting part yet. You can see that this draw is same as this draw, and you can see the similarity between line segment and dot. But I haven't introduced, I'm leading to there, a class hierarchy yet. So dot and line segment has very similar very similar functionality and even some of the common data points, which means that I can actually abstract some of the commonalities between them. So I basically can create another class called, well, picture item, and then I can move some of these things from commonalities between dot and that and into there, which is that I have all of these have a canvas. So I can actually move this from here to there. And then there is another commonality that all of them define a draw function, which I can actually do this. So now a line segment is a subclass of and then dot is also a subclass of and then we don't need this thing. Why do we need the canvas anymore? Because this one is a dot is a subclass of picture item. Subclass means that it inherits whatever that father class, that superclass have. So picture item is a superclass of dots. So dots have everything picture item has. So here it has a canvas field, and so this one have that canvas field. Why can't we access it? Because this one is defined as private. If you want your field to be visible to your subclass, but not others, there is another keyword called protected. Protected means that this field is owned by you and all your subclasses, but not others. So now if I change it to protected, you can see that you can actually change and use the canvas here and here. So this is one interesting fact about class hierarchy. This class is a superclass of that, and it can access, it not only can access, it basically contains a body of this thing. So you can see this one, the line segment, is a picture item. So whatever picture item has, line segment also has. So picture item has a canvas. So line segment have a canvas. And that's the first thing, the data inheritance. The second is that a draw a method. So the method here, you can actually define this as does nothing. This one does nothing. And well, this one is different. It has a draw, but it does something. So this one is called override. Override, which means that, well, remember line segment is a subclass of picture item. And so since this one is a subclass of that one, so it has everything picture item has. So it also has a draw function. But this line segment doesn't like the way a draw behaves. It likes its own behavior. So it redefines this thing and then introduce its own functionality, similar to dot. Now you may ask another question is that why do we want to do that? The reason is that now you don't have to care that much about whether a item is a dot or line segment or whatever others is, that you can just use it. So here I have 100 dots. I can use a loop to draw them all on the canvas. What if this thing is not a drawer of dots? This thing is a drawer of picture items. And one thing you can do is fill them all with dots, still dots. If you fill them all still with dots, you can actually picture them out. So you can see actually instead of creating a drawer of dots, I create a drawer of picture items. And then there was 100 of picture items. I fill them with dots and then draw them all. So now I'll still draw 100 dots. And if I run them, you can see that this is similar with what we saw before. There's not much interesting. To get it more interesting though, we can actually mix and match them. So basically, instead of filling them all with dots, maybe I want to fill them with something else. Okay, what about this? Now I fill them every other one with dots. And then I fill the other half with line segment. So you can see that we have a drawer of 100 items, and 50 of them are dots, and 50 of them are line segments. And I can use a singular function, a singular loop to draw them all. And let's see what will happen to this one.
Oh.
So this is 50 dots here, forming a close resemble a line. This is 50 line segments drawn by this. And if you want to see this, how they're drawn, we can actually introduce a delay here. Don't worry about that. This is just a delay, so we can see how they are actually drawn. And oh,
It just appeared.
oh no. I see what's the problem. So basically, I
Yep.
introduce this at the wrong place. I need to introduce the delay when we draw them instead of creating them. Here.
Oh.
So this is how it's done. Remember that, see this how it's created. So basically, every other one is a dot, and every other one is a line segment. So what it does is that it draw a dot and draw a line segment, a dot, a line segment, a dot, line segment. And one interesting fact is that it just called draw, and it seems to be a picture items draw. And how does it know which one to call? That's the interesting part of object-oriented programming. The object itself contains the information about which draw function to call. So it automatically knows that when it picks an item here and they take a look at the item, if it's dot, it will draw here. And if it's line segment, it will draw that one. So that is how it's done. And this is another example about object hierarchy and also object orientation.